All right, guys. So in our last video, we talked about association, okay, and interpreting the scatter plot. And it was all about using the right verbiage, right? So when you talked about the relationship of the points on the graph and the data values, you just wanted to describe it in terms of does it go up, does it go down? So does it have a positive versus a negative relationship? Or is there no relationship there at all? If it's going up or down, then does it have a strong connection to each other, or is there a weak connection? Is there a weak trend? Um, and then lastly, you were just describing whether or not it formed a nice predictable straight line trend, or if it was nonlinear, in which you couldn't really predict because it wasn't a straight line. It was either scattered all over the place or following some curved path. Okay. So today, right, we're going to go a little bit farther in interpreting the graphs. And we're going to be talking about, right, what's called a line of best fit. And it's almost exactly what it sounds like. Okay. So a line of best fit for us, right, is very simply defined. So line of best fit. Okay. It is a prediction line. Well, so it is imaginary. That cuts through the middle of the data points. Okay, and it's just arbitrarily drawn through the middle of all the points. Now it's also called, okay, so AKA, it is a trend line, and you can look back and on the previous video and reference me talking about the trend of the data. Well, this is an actual line that's going to, right, describe that trend, right? And it's going to allow us to come up with the linear equation, okay? Trend lines will be written in slope intercept form. Okay, so y equals mx plus b. In which case, right, we should know that is your slope. That is your y-intercept. Now, something to note, right? When counting slope, you must consider the intervals. Right? When you count the slope, we're no longer always going to be by one. Okay, so you have to consider the intervals that you are counting over when you come up with your equation. Okay, so we've done this. We've looked at graphs, right? And we've come up with equations. So you could review those notes, right? Where we went from one point to the other point and just counted up and over or down and over, and you came up with the slope. Okay, but that changes a little bit here because, right, we no longer have a one-to-one relationship for our x and y axis, right? So let's look at just a very generic example of what data could look like, right? So we have our data points here. And we can just kind of put some random points here and there. We'll trend it down so that things, right? Okay, so there we have it, right? So there's our data points. And if we look at our data, we've got a couple different options here, right? We don't want to necessarily connect, just connect dots, okay? Because sometimes those dots don't quite line up the way we think they should. So maybe if you took the first and the last dot in this data set, and that was something that looked maybe like that. So you can see that that line, right, doesn't quite follow what I would think is the middle. It does connect a lot of these dots, but if you'll notice, right, we've got kind of this, I think it's more tilted, right? It's going to fit better. You don't have to connect the dots, okay? So this one, right, red line's going to be a no, right? That did not follow our data trend. And again, you could look at another line here that cuts through and maybe connects this point with that point. And again, you can see, right, we are connecting quite a few dots here, but not really following just the overall pattern of data. Okay, so orange line is a no. But if you go through and look at, right, just kind of an arbitrary line, not really connecting points, but that just kind of goes down through the middle of the data, you'll notice we've got a little bit of data on top, a little bit of data on the bottom. And it's really following the pattern, right? So it is a negative slope. So things are trending down. This has got some data on top, some data on bottom, and it's just kind of splitting that difference there. Okay, so it's not about connecting dots. It's about splitting the difference. Okay, it's just about getting through the middle of the data set. So when we draw a trend line, we want to make sure that it goes through the middle of the data set. All right, so let's go ahead and create some equations, right? Let's look at some real graphs and think about like an equation and how we create those equations again. All right, so looking at graph number 1, right? So this one has to do with math test scores, all right? And so you can see you've got the exam score, what the student scored, and the hours that he spent studying, all right? Now, is this always true? Is it true that if you study a lot, you make a better score? Well, no, right? That's not a guarantee by any means that you will get a good score just because you studied a lot. But, right, we can say there is some sort of relationship here. If you can see the trend line, right, if you can see the way the data is tracking, it's fairly obvious, okay? For the most part, right, we want to cut the data down the middle. So I'm turning the graph so that I can draw kind of a line down the middle. And so I'm just going to kind of place my little piece of paper here and following that data. Okay, so it might look something like this, and they don't have to be perfect. They're not always. Your answer choices aren't going to be exact, right? But I've got kind of this trend line, and you'll notice I've got some data on the top, some data on the bottom, and I'm for the most part, I am following, right, down the middle of the data set. Now, notate still, guys, right? We're still gonna talk about this guy over here, okay, and this guy over here. Those are kind of weird exceptions, right? So this guy didn't spend very long at all studying and made a very good grade. We all know people like that, okay? That they just get it, right? They can do those things, or maybe they just guessed very luckily, okay? While as this person, right, tried very hard, studied more than most, it looks like, and didn't do so well. And we've all been in that situation as well. Okay. So is it a guarantee, right? No, right? There's not a guarantee. And that's why they call it a correlation or an association, right? Because you can see the relationship is that typically, right? Typically, the more you study, the higher your scores. That is the trend. Okay. But are there exceptions? Yes, right? This is what we call association or correlation. Okay. There's another term used in mathematics, and that is causation, right? And causation means there is a direct link. Okay. So in this case, right, we do not have causation. Just because you study a lot does not mean you get a good score. It means you have a better chance. All right. And those are two different things. But let's go back to thinking about how do we create a mathematical equation, right? Um, how do we use something, okay, in the form y equals mx plus b to describe this graph? All right. So if you look at this, right, should be the easier one. That's going to be our y-intercept. Right? So we look at the y values, right? This is the y axis or axis. So we're going to look and see about where does that hit? Well, for me, right? For me, that's going to hit somewhere between these two. Okay. And I'm going to just go with 20 because it's marked, right? So I'm going to put it right there and think that that's about the y-axis. I don't have to be specific. I don't have to call it 28 or 26 or maybe where it hits, right? I'm just going to call it 20. It's pretty close, right? It's closer to that than 40. Some of you might say, well, call it 30. And we very well could, right? We could call it 30, and that would suffice for me. So either way, right, we know what our y-intercept is. It's right over here. Okay, it's where that line's approximating to hit, right, for that amount. All right, so given here, right, we have a y-intercept of 20. All right, now we can work backwards. So we know there's an x there. Now we just need to fill in our slope. Okay, and this is where you got to be very careful. Right, now I drew my trend line. All I need to do is find some points in which that I can follow from one to the other and count. So this point right here, right, looks pretty good. Let me use a different color for us so that we can follow along, right? I'm going to go with this point right here, and I'm going to count to this point right here. All right, so I'm just going to go up 1 over 2, up 1 over 2, right? So that might lead us to want to say, right, that our slope is 1/2 because, well, that's how we did it before, right? But consider, right, this is not 1 and 1, right? How much are we talking about here? If I went up 1 space in the y direction, I actually went up 10 points, right? So really, I went up 10 over, okay? In this case, right, how many is 2, right? How much is 2 worth? Well, if it's 1, 2, 3, 4, right? There's 4 gaps between each one. Okay, so you can see I've got 4 gaps there. That means each one of these is 15 minutes. Because, right, that's an hour. 15, 15, 15, 15. So I went up 10 points over 30 minutes. Right, and this again takes us back. Okay, what is our real world rate supposed to always be? Well, it's supposed to always be per 1, right? And if you'll notice, we have hours. So we want to talk about slope in terms of per 1 hour. Right? So if it's 10 for 30 minutes, then to keep that equivalent, I would say it was 20 for 60, right? Which is our 1 hour mark. So 20 points per hour of studying is a good approximation. So what is my slope? My slope is 20, right? So there is my equation, y equals 20x plus 20. So 20x plus 20, right? And does that fit? Is that what I would expect? Well, let's see. Let's say you studied for 2 hours. Okay, what would you expect your score to be? Right? 2 hours. What would you expect your score to be? Well, that means I put 2 in here. X is in hours, right? So 2 hours, that's my X value. That means I'd put 2 right here for the X. 20 times 2 is 40, plus 20, 60. All right, so let's see, at 20, if I go to 60, well, there I go. I hit right there, almost on the trend line, right? So I know I've got a really good equation because it is predicting along itself, right? It's saying along these lines what I should have, okay? So let's look at another example, okay? And again, making sure that we just identify things as they are, right? So this one, okay, got kind of a almost a curve look to it, but hey, you know, we can probably squeeze a good line of best fit out of there. And so I'm going to go something like that looks pretty, about half of them above, half below. So maybe right in there. So we're going to go ahead and draw that line, right? That's my trend line. Okay, so looks pretty good. All right, so draw a line that best fits the relationship, write an equation for the line. Well, this one's a little tougher, right? Because we can identify the ticket prices, right, of going from 0 to 20 to 40 to 60 to 80. That's fine, right? Because we've got 0 right here. But if that is 0, then this cannot be 95, right? This is something else, because, right, we can't go from 0 to 95 in that short span and then move to 2000, right? So this would not be a good y-intercept anymore, right? So we've got to consider how many years. All right, so I've got 1, 2, 3, 4, 5. Okay, so from there to there is 5. So this must be 94, which means, right, I've got 0. Well, this would be like year 1, okay? And year 2 and 3 and 4 and 5 and then 6. And so then we've got year 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Right? So we've got to be careful with years, right? When they're counted out as that many. Well, it's okay to say, you know, 1 year, 2 year, 3 year, because you're measuring from 0. But when you say 95, well, that's not from 0 anymore, right? That's from well, that is from 0, but there's 1,995 X's before this one, right? So we've got to account for that. We've got to adjust. But in looking at this one, right, again, I'm looking at y equals mx plus b, and I'm thinking about, right, our ticket prices over time. All right, so in we're looking at this, right, our y-intercept, we kind of came to the 0 mark, right? So it looks to me like we're only going to have slope here, right? We have a y-intercept of plus 0, which is okay. We can start at 0. So we have kind of a starting point, and then in 95, it goes up a little bit, and it goes up from there. All right, so what is our up and over? Let's pick some good spots. Okay, this one doesn't look too bad, right here doesn't look too bad. Going kind of up and over, up and over, up and over. This one looks pretty good too. Okay, that could be, we could go from there to there on my line, right? So we could go up 1, 2, 3, okay, and over 1, 2, 3, 4, 5. Okay, so going from that to that, looks like I went up 3, but are they worth 1? That's the case, right? So if I went from 0 to 20 and there are 1, 2, 3, 4 of those, then that means each one of these has to be worth 5, 10, 15, 20, 25, 30, 35, 40, right? So each one of these is actually worth 5. So I didn't go up 3, right? It's not 3, it's up 15, right? Over. Now I did go by 1 year at a time, okay? So 1, 2, 3, 4, 5. So I've got 15 over 5. In which case, right, we always simplify. So that's $15 in 5 years. We should be able to say it's $3 in 1 year, which is great because that's what we want our real world slope to be, is per 1. So coming back to our equation, right, we've got a 3. So y equals 3x. So pick a year past 1994 and see if it fits the mold, right? So let's talk about maybe year 12, okay? In the year 12, what would we expect our ticket prices to be? And so we would put 12 into our equation. So 3 times 12, which is 36, plus 0 is 36. So 12, 36 should be pretty close to where I want to be, right? So if you go to 12, just here, right? And we go up to $36, which is just a little bit above that 35 line. You can see we do hit right on our trend line. So we've got a good equation that's going to help me make a prediction. So you could ask, well, 30 years, right? At 30 years past 1994, what would the ticket prices be? Well, if they continue this trend, right, we don't need to see it on a graph. We can simply put 30 in there. So in 30 years, if this continues, right, if this trend continues, in 30 years, our ticket prices could be $90, right? That's crazy, but that is how they use bivariate data in real life, right? And this isn't far from what we would track, okay? Some kind of price over time to see the increase in it, okay? So that is lines of best fit, guys. That's trend lines, right? We've done y-intercept. We've done slope. The big thing for us today is that we want to remember that our units, right? Our units are going to determine how much each step is worth. In this case, right, it was 5, 5, and 5. You've got to make sure you account for that. We can't just count up 3 over 5. The slope is not 3/5 in this case. It is, right, 15 over 5. All right. So make sure you count your slope correctly. Make sure you identify the y-intercept as, right, what it is according to the trend line. All right. So any questions, comments, or concerns? Again, always just give me a message. I'll get back with you as quick as I can. Thanks, guys.